Extract the demo sample files into the demo folder. This includes both the C++ demo and the C# demo. Double-click the C++ demo folder to open the solution file. Right-click, select Microsoft Visual Studio 2022. Right-click and select Build. Open the WIN32.cpp file. Search for the main function. The variable value of 2513 is true, which indicates the current gateway model being used is WIN2513. Next, configure the COM port for the WIN2513 gateway. Open Device Manager to check the current COM port. It shows that the current connection is on COM6. Therefore, set the function parameter to 6 minutes accordingly. Attempt to run the code. A system error appears with the message, "Missing dynamic library file." Navigate to the demo folder. Enter the WIN64 subfolder. Copy the 32-bit dynamic library file WIN32, DLL. Paste it into the debug folder. Return to the Visual Studio interface and continue execution. The program now runs successfully, detecting both ID5 and ID6. Proceed to initiate the homing operation for ID6. Press N1 button of I or O board to test the sensor trigger function. The program will now enter cyclic motion testing. It displays the current test count and continues performing aging tests. This concludes the demonstration of the C++ demo. Next, proceed to the Win64 system environment demonstration. In Visual Studio, select x64 as the target platform and compile the project. Check the generated Win64 demo files in the x64/debug folder. When running the program, a runtime error appears, indicating the absence of the 64-bit dynamic library. To resolve this, copy the 64-bit dynamic library file. Navigate to the WIN64 folder. Copy the liburst Win64 DLL file and paste it into the x64 folder. Run the 64-bit program again. It should now execute successfully. As before, trigger the homing signal by clicking N1 on the connected I or O board. The demo will enter cyclic testing. This concludes the demonstration of the 64-bit demo. UI robot. Simple, robust, compact.